Welcome back, everyone. Just following up on a little fun project I wanted to do, and it's where I put an ESP8266 module, or 8266 module. I can never keep that straight. Inside the model of a Terminator T800 CPU, and put a standard header on the bottom. And in this segment here, I'm just showing the fine wires that I soldered in to go between the original 8-pin header that came out of the bottom that I removed, down to the 8-pin header that was inline. Once I got those tiny little hair type wires soldered in, it was good to go. They're specifically for jumping, and they're really easy to use. Your soldering iron burns the enamel right off them. I mean, you get two little spools, as you can see it on the left there, is about $1. Anyhow, I got that done. Welcome back, folks. A little while ago, I had my last test print in orange PLA, and I'd mentioned that I was going to take an ESP8266, in this case a version 1, and I was going to mount it into a Terminator T800 CPU. So I printed the file out, which was easily found on Tinkercad, and I was messing around and figured out all the cavities I'd have to create in it and print in the two halves of the clamshell. I'm just going to move my fill light here because it's driving me nuts. As you can see, the wires are quite fine. I have some, I don't know what the gauge of that wire is, but it's for fixing jumps and traces and cell phones and stuff. And it's enameled, but the tip of your soldering iron burns the enamel off as you're tacking the trace down, so it made it really easy to do. And I just took the top row of points on the original 8-pin connector on the ESP, and I gave the first 4 pins are the top row, and the last 4 pins are the bottom row to make the wiring easy. Inside, this is the other half of the shell. I was playing with a different way of printing this one, so it didn't come out as good as that one. This one I printed cavity facing up. This one I printed cavity down, and the top actually came out a little better because that's what was on top, and it wasn't too hard actually to pull the the support material out of the cavity. This one, however, I pointed cavity up, so of course the cavity came out nice, and the support materials between these, and this came out alright, but it sort of screwed up the detail that was in here. So what we're going to do here is show you what that looks like closed up. I haven't glued it yet, and I did show, at least I'm pretty sure I'm shown, or if not I'll put some pictures. If I can hold that there. There's little holes there that were kind of a happy accident of the slicer that will serve as vents should there be any warmth. I don't think, nothing ever really gets warm on that. And there's a little bit of opening here and there, but there's actually, I don't know if you can hear it, a little bit of flex. So that'll close when I give it a couple drops of crazy glue or this kind of stuff, super glue. I use the foam safe stuff in general because then I don't worry about it. It doesn't fog up clear plastic or of course melt foam. It doesn't get warm as it cures, but it does cure a little bit slower. So I'm going to put this cap on and glue it on. But I do need to remember which side is the top, so to speak. And I can tell right now from the errors in the print which side is top, but I really need a way to mark the top and put a little black notch for the left. And I'm going to glue that down now. In the next video, should be getting this plugged into the circuit and being very breadboard friendly now. And it should be quite solid actually after that. You'll be able to just handle this without worrying. Anyhow, I'm going to glue that and come right back. Welcome back. A little bit further along, I did get that ESP module, the version 1, into the Terminator-like CPU casing. It puts it to 8 pins in line, so it'll go straight down into a breadboard, as you can see. The only things I've really changed on this board since the last time it's been on is the layout for this. Now, instead of being the way Hari had his and the module he sent me that had the 4 pins on either side of the split in the breadboard, it now fits 8 in a line. So I just moved the pins around for that. I added some capacitors earlier for some stability. Now, for some reason, this module that I have that I'm using to supply my USB power up here is not letting enough amperage through, or it's not powering it completely sufficiently. We'll just do that to power it up, but it'll go through its boot sequence. So it is running. And right now the motion sensor, which is this thing right here, is, oh, there we go. It saw some motion. The thing is though, it's gonna lock. So what's gonna happen is the part of the circuit that this is on is feeding back through a resistor to tie it low, because it outputs high. So it's being brought low, just low enough that it'll look like a low, into the PCF chip, and that's a I2C bus GPIO expander, and doing that allows this item here, oh no, didn't get into a lock state, allows that item there to invert its sensing state. The PCF wants to see something pulled low to be on. I got that backwards. No, it wants it pulled high. Yeah. Oh, it saw the end of this tip. So actually, that's actually working. But as you can see, my 12.7. It's actually a rock solid 12 coming out of that power supply. There's something wrong in that module, not allowing it to give the full amount. So I'll have to have a look at it. I suspect something in the switching power supply. But anyhow, so we have the I2C extra GPIO chip right down in there. It's just a little IC. Then we have a dual channel level shifter. I mean, obviously I2C is what I'm using it for, but really it can level shift for any purpose. I forgot the type of, I think it's CP2901 or whatever. It's a very common chip. I like it because it has its extra function pins broken out on the side, which allows you to use this one extra wire when you're plugged into the Arduino IDE on the RTS, and allows you to flash your ESP modules exactly like an Arduino. There's no funny business. It just can reset them and make them run. He's working over there. Little LED coming on and off. I must have moved this just enough. I'm using that for the power right now, and it's more than capable of powering up this. Although I have a feeling the input voltage is too low for it. So it's seeing an input voltage of exactly 5, and this is probably dropping it down too low to get the power that this needs. And actually, more so, it's probably the combination of this and that at the same time. I do have a direct power tap here that I could put on it, this little fellow, but I can't remember where I left the lead for that. So anyhow, it just happens to be working now, so for this shot, so we'll go with that. The board is not anything too special, and the mock Terminator CPU Just has that wonderful red glow, and the camera probably can't see it. I'm gonna have a look right here. When it's in motion, when this sees motion, and this LED is lit up, which is actually, oops, jabbed it. This little LED is actually on the I2C expander. When that's lit up, every so many seconds, the ESP is going to transmit through the serial bus that it's seeing a motion. And when it does that, you'll see there's a little blue flicker here. Just like a little bit of heartbeat. I don't know if it's going to show up on the video. Oh yeah, you can see it dim for a split second. When the red dims for a split second, what you can't see is there's also a flash of blue that just isn't being picked up. And when there is a motion event on, you'll see the heartbeat being sent, which would be going into a terminal or whatever, telling it when it last saw motion or whatever's going on. But its ambient temperature in here is pretty cold, and my hands are pretty warm, and actually even this plastic is warm, so who knows what's triggering this this little fellow here. And yes, I have some big silly wires. They were just things to get this going quick and dirty. Everything is pretty much the same as it would be for the normal ESP module. We have, I'm just going to go through right quick. We have a resistor that pulls the reset pin or the program pin high, and that's the one that goes out here to the RTS here. We've got a couple more pins pulled high. I think that's the enable, and that's, I can't remember why that one has to be pulled high. It's to do with the I2C, I think, actually. Then we've got the wires coming over for I2C down into here, and that is the blue and green, and then that becomes the green and orange over here. It takes the output from this IC, and most of this IC here I have small metal jumper wires for all the real mundane powering and setting its bus address. Then we have the sensor wire, yellow one over here, and then down below we have the yellow wire feeding the LED, and this big green wire out here is just a ground to bring it around from one side of the board to the other, because I had that power module on the end of it. And just some capacitors that I had jammed on there because I thought I was having some instability. This side of the rail, if you see the orange, it's that's the 3-volt side. There's the red wire coming into the back. That's the 5-volt side of the board. And then we have the blue and green is our serial cable, and the yellow is the DTR, I believe, part of the ability to reboot that after programming. Anyhow, that's all pretty straightforward and very boring. The most important thing, or the fun thing, is that yes, I got the I'm just going to take it out here for us while we're here. Might as well do that. Unplug that. I'll just do this right on camera, and hopefully one of the pins doesn't come out just to spite me. You can see that's the that's now the ESP module. Actually, you can see it. You can just see it in there. Let's see if I can jam it back in. Oop, I bumped the camera. Oop. Yeah, black dot. It's polarity specific, so you wouldn't want to get that wrong. As always, thanks for watching. Like if you like, and don't forget to subscribe.